Hello, everyone, and welcome to the OneClass channel. My name is Donna and I'm a recent master's graduate in the Materials Science program from the University of Ontario Institute of Technology, also known as Ontario Tech University. So I also took my Bachelor's of Science at this institution as well in the Pharmaceutical Chemistry program. So today we're going to go over some commonly asked questions in chemistry at the high school, college, and university level. So if you needed any help with homework or tutoring, check out the links in the description below. So now I'm going to get started on our set of questions for today's session. Okay, so question number 1 asks, what is hybridization? This is a good question. So let me write out the definition of hybridization plus a common example. So hybridization is basically when you combine two molecular orbitals to produce a new hybrid orbital. So first, let me give an example of just normal methane. If you were to write out this molecule, you have just a carbon, and attached to it are 4 hydrogens that are all equivalent. If we didn't have hybridization, then its molecular orbital diagram would look like the following. You would have your electrons there. And then for the 4 hydrogens, they would all be at different energy levels. But we know that this isn't true because all of the hydrogens should be equivalent in energy since they are all the same. So this is when hybridization comes in. And your new molecular orbital diagram will look like the following. This 1s would still be the same, but now we have two sp3. And here you can see all the electrons are at the same energy level. Okay, so let me write out why this is. So since we know that the 4 bonds in CH4 must be equivalent, so therefore we have to promote the 2s orbital, so make it a higher energy. And we have to denote the p3 orbitals. So make them have a lower energy. So basically so that they meet up in the middle. And this is to form 4 new hybrid orbitals called sp3. sp3 hybridization. Making them all equal in energy. So if we were to write out that same CH4 molecule, you'd have the carbon in the middle. Let me write it smaller. So you have the carbon in the middle with its 4 electrons. These are its 4 valence electrons. And then around it are all of the hydrogens, each with their valence electrons as well. And then I'm just going to circle just to show how they all share. Sorry. Kind of look like this. So when you have an overlap that looks like it's a head-on overlap, these are called sigma bonds. And since the carbon has 4 bonding groups, so bonding groups can either be a bond to another atom or it can be a lone pair. So in this case, it has 4 bonding groups, each to 4 hydrogens. So therefore, we would say that this carbon is sp3 hybridized. So let's see what our junior tutor said. Hybridization, or orbital hybridization, is the process of combining 2 molecular orbitals to produce a new hybrid orbital with different shape, energy, etc. The purpose of hybridization is to optimize the bonding with other atoms. Yep, pretty much this solution is correct. I'll also type out my example. Okay, so I said that this solution is correct. For example, in CH4, there are 4 bonds that must be equivalent to each other. So by promoting the 2s orbital and denoting the 2p orbitals, this forms 4 new hybrid orbitals called sp3 hybridization, where all the electrons are equal in energy. Okay, so let's move on to question number 2. What is an oxidizing agent? So basically, oxidizing agents they cause the oxidation of the other chemical species. Chemical species. So simply put, they are the species that gets reduced. That sounds kind of confusing, an oxidizing agent getting reduced, but you can see it as they cause the oxidation of the other chemical species. So as you can guess, the opposite of this is reducing agent. So reducing agents cause the reduction of causes the reduction of the other chemical species. As you can guess, this is the species that is oxidized. Okay, so let's see what the junior tutor said. Chemical species that accepts electrons in a redox reaction is known as an oxidizing agent. In other words, the oxidation agent causes the oxidation of other chemical species. Electronegative elements like halogens, nitrogen, and oxygen act as oxidizing agents. Let us see the following reaction. So they have manganese dioxide plus hydrogen plus just hydrochloric acid makes water plus manganese chloride plus chlorine. Here, the manganese oxide is an oxidizing agent because it caused the oxidation of the chlorine atom to Cl2. Yep. So this solution is correct. Okay, so let's move on to question number 3. What is Hunds rule? So there are 2 parts to Hunds rule. The first one is that every orbital in a sublevel is singly occupied before any orbital is doubly occupied. And the second part of Hund's rule is that all of the electrons in singly occupied orbitals have the same spin. Okay, so this makes more sense when you actually put it into practice. So let's look at oxygen, for example. So the number of electrons in total for oxygen is 8. Okay, so let's draw out our diagram showing all the different orbitals. 1s, 2s, and then 2p. Okay, so we're going to start from the bottom and just count out just all the electrons as we write them in. So starting at the bottom, we go 1, 2. So notice that first in every orbital, you have the electrons go spinning up. We do the same thing here. So 3, 4. And then when we get to like the 2p orbital, it's gonna be 5, 6, 7. So this is what the rule means when it says all of the electrons in a singly occupied orbital have the same spin. And it also shows that every orbital in a sublevel is singly occupied before any orbital is doubly occupied. So we have the 7 and then 8. So this is the correct way of writing this. Just for comparison's sake, let's look at what happens if we did it the wrong way with 1s, 2s, 2p. This is when you would just go like 1, 2, like pointing up, 3, 4, 5, 6, 5, 6, 7, 8. Yeah, like something weird like this. So don't do this example. Okay, so let's see what our junior tutor said. Hund's rule tells us two things. First, that every orbital is singly occupied before coupling, and second, that all of the electrons in the singly occupied orbitals have the same spin. To illustrate, they have the 3 electrons all pointing up, which is the correct way. If you were to do this the wrong way, you have 2 electrons pointing up and then 1 pointing down, or you have 2 electrons in the first and only 1 in the second and none in the third, so that is wrong. So this solution is correct, and they gave pretty good examples as well. Okay, so now let's move on to question number 4. What is the definition of sublimation? So generally speaking, Sublimation is a phase transition from solid straight to gas. So what's cool about sublimation is that it doesn't pass through a liquid phase. And then I'll just write out, let's say we had a metal solid. When it sublimates, so each metal may have a certain sublimation temperature, and once it reaches that temperature, it'll turn into a gas. So let's see what our junior tutor said. Sublimation is defined as the phase transition from solid to gas without passing through an intermediate liquid phase. It is an endothermic phase transition that occurs at temperatures and pressures below the triple point. Take note that the sublimation term only applies to physical reaction and changes. Any phase changes from solid to gas through chemical reaction is not defined as sublimation. So basically it has to be a natural phase change that occurs when there's a change in temperature or a change in pressure. Like if you added oxygen or something to your metal and then it turns into a gas, this doesn't count as sublimation. So desublimation is the opposite process of sublimation wherein a gas undergoes phase change into solid form. Below are some examples of sublimation. Dry ice sublimates into carbon dioxide vapor at room temperature and pressure. I'm guessing freezer burns occur due to the sublimation of ice into water vapor. And finally, naphthalene balls readily sublimates at room temperature and pressure. So this solution is correct, and they gave good examples as well. Okay, so now let's move on to question number 5. How many ounces are there in 1 gallon? Just a simple conversion question. It's basically the conversion ratio is that there are 128 ounces in 1 gallon. Let's just have an example of putting this into a real life situation. Let's say we wanted to know how many ounces in 10 gallons. So I'm going to first put whatever units I'm looking for on the top. So it's going to be X ounces over 10 gallons. That'll be on one side of the expression, and on the other side, I'm going to put our conversion factor. So 128 ounces over 1 gallon. And now we just solve for X. So whatever units you're looking for will be on top. Whatever units you want to get rid of will be at the bottom. And you also can tell you did it right if your units cancel out nicely. So our gallons will cancel out and we are left with ounces. Basically all this all this equation shows is that we multiply 10 to 128. We end up with 1,280 ounces in 10 gallons. Let's see what our junior tutor said. As a general knowledge, I wouldn't say it's general knowledge, but we know that 128 ounces is equal to 1 gallon. Thus, we can say that for every 1 gallon of liquid, we can also express it as 128 ounces. So this solution is correct. Okay, so now let's move on to question number 6. What is ammonia? So I'm going to draw out the chemical formula for ammonia. It is NH3, and it's also a stable binary hydride, sorry. It's also usually in its gas form, and it is produced naturally in the body, like through metabolic processes. And in nature. We can also draw out its Lewis structure, just showing that there are 3 hydrogens, and you'll also notice that it has a lone pair. So I'm also going to add, since NH3 contains a lone pair, it can act as an electron pair donor. Otherwise known as a base. So let's see what our junior tutor said. Ammonia is a colorless and pungent compound composed of nitrogen, which is the central atom, and 3 hydrogen atoms. It exists naturally and can also be synthesized through Haber process. One of its significant contributions to the ecosystem is its function as a precursor to foods and fertilizer for terrestrial organisms. It's a nice fact. So ammonia has a molecular geometry of trigonal pyramid. Sorry, I can never say this right. Pyramidal, as predicted by the Vesper theory. This is due to the presence of a lone pair in the central atom. Figure below is the Lewis structure of the ammonia. So this solution is correct. Okay, so question number 7 asks, how many yards are there in a mile? Okay, so this is just another conversion factor question. Basically, there are 1,760 yards in 1 mile. Okay, so let's try to do an example when we would need to calculate this. So let's say we are asked how many miles is like 10,000 yards. So I'm gonna put what I'm looking for first as the numerator, x miles over 10,000 yards. Then on the other side, I'm going to write down the conversion factor. In the same order, we have miles on top since this is the units we want to convert to. And then 1760 yards. These are the units that we want to get rid of. So now we just solve for x. All we do is multiply out 10,000 yards. And you know you have done it correctly if your units cancel out nicely. So in our case, the yards will cancel out and we're left with a value in miles. Is approximately 5.68 miles. Okay, so let's see what our junior tutor said. To answer this, we use dimensional analysis and the appropriate conversion factor. 1 mile is equal to 1,760 yards. Convert using dimensional analysis. Okay, so this solution is correct. Now let's check out question number 8. What is the molar mass of ethanol? First, I'm going to write down the chemical formula for ethanol. First, we can actually write out its structure. So since we have eth, that is our parent carbon chain. So this means there are 2 carbons involved. And you'll also notice that ethanol ends in -ol, so we know that one of the carbons will contain a single alcohol group, which is just OH. So now that we know this, I'm going to draw out my OH first. And then, since carbons need 4 bonds attached to it, I'm going to fill out the rest of the bonds with just all the hydrogens. So this is the formula for ethanol, well, the structural formula for ethanol. You'll see that it contains 2 carbons, 1, 2, 3, 4, 5, 6 hydrogens, and 1 oxygen. So it can be written like that, or you can show that it has an alcohol group, so it's C2H5OH. But nonetheless, when you want to answer a molar mass question, first we are going to figure out all the different atomic masses of the elements that are involved in ethanol. So first, you look at the periodic table and try to find out the molecular weight of carbon. You'll see that it is 12.01 grams per mole. If we were to find the molecular weight of hydrogen, it is 1.01 grams per mole. And lastly, the molecular weight of oxygen is 16 grams per mole. So finally, if we wanted to find the total molar mass of ethanol, so molar mass of C2H5OH, it is going to be the molar mass of carbon times 2 plus the molar mass of hydrogen times 6, since there are 6 hydrogen atoms in ethanol. And then finally, it's just 1 times the molar mass of oxygen, since there's only 1 oxygen atom in ethanol. Now I'm going to sub in the values. And then if we add it all up, we end up with a value of 46.08 grams per mole. So let's see what our junior tutor said. The molar mass of ethanol is 46.08 grams per mole. In calculating the molar mass of a compound molecule, we use the equation below, where N is equal to the number of atoms present in the compound, Mi is equal to the molar mass of individual elements present. So you can see they have the molar mass is equal to the sum of N times M. Yeah, so that's an easy way of putting it as well, if you like to see it as a nice math expression. For ethanol, we have, and then they summed up all the elements that are present, carbon, hydrogen, oxygen, how many atoms there are of each. So there's 2 carbons, 6 hydrogens, 1 oxygen. Then they also have the individual molar masses of each of the atoms. So 12.01, 1.01, and 16. Then they calculated molar mass and got the same value as me. This solution is correct. Okay, so now let's look at question number 9. How do you convert from meters per second to miles per hour? So let's just look at the units that were given. So we start off with meters per second, and we want to find out what this value is in miles per hour. So first, we need to find out the conversion factor for converting seconds to hours. So there are 3,600 seconds in 1 hour. And converting meters to miles, there are 1,609 meters in 1 mile. So now let's write it out as an expression to see how our units should all cancel out. Let's say we have x meters per second. The first thing I want to do is convert seconds to an hour. So to cancel out the seconds, I need to multiply by seconds. So it's going to be 3,600 seconds over 1 hour. So this will cancel out our seconds. And then again, I need to multiply by our conversion factor to cancel out the meters and get miles. So now I'm going to put my miles on top, since this is the units that we're looking for. 1 mile over 1,609 meters. So you'll notice that our meters will now cancel out. So this leaves us with an x value of 2.23 miles per hour. which is also equal to 1 meter per second. Let's see what our junior tutor said. We will use the following conversion factor to convert the speed in meters per seconds to miles per hour. So 1 meter per second is equal to 2.23 miles per hour. We multiply this conversion factor to give the given speed in meters per second. For example, the speed of sound is 343 meters per second. Oh, really? And we need to convert this speed to miles per hour. They have 343 meters per second. And then they multiply it by this conversion factor of 2.23 miles per hour per 1 meter per second, and you get 767.269 miles per hour. Therefore, the speed of sound in miles per hour is 767. Yep, so this is correct. I'm also going to add where they got that 2.23 value from. Okay, so I showed that since there are 3,600 seconds in 1 hour and 1,609 meters in 1 mile, we can show the units canceling out in the following expression. 1 meter per second times 3,600 seconds, seconds over hour, times 1 mile over 1,609 meters is equal to 2.23 miles per hour. So this solution is correct. Okay, so moving on to question number 10. How do you convert quarts to gallons? So the relationship between gallons and quarts is that 1 gallon is equal to 4 quarts. So let's have an example of where we would need to calculate this in like an everyday situation. So for example, how many gallons is, let's just give like a random number, 27 quarts. Okay, so then whatever units I'm looking for, I'll denote as X gallons. And it'll always be in the numerator just to make things easier when we have to calculate the math. So X gallons over 27 quarts is equal to 1 gallon over 4 quarts. So now I just solve for X. Again, you'll know if you do these conversion questions properly if the units that you're trying to get rid of should cancel out nicely, and you should be left with the units that you are looking for. So basically, this is the same as saying 27 divided by 4, which is 6.75 gallons. Okay, so let's see what our junior tutor said. To convert quarts to gallons, we need to remember the relation 4 quarts to 1 gallon. For example, 1 quart is 0.25 gallons. This solution is correct. Okay, so moving on to question 11. How do you convert 4 liters to milliliters? So first, let's recall that 1 liter is equal to 1,000 milliliters. So then we can just solve for milliliters. So I'm going to put X milliliters over 4 liters is equal to 1,000 milliliters over 1 liter. Now just multiply both sides by 4. Okay, so you'll notice that our liters should cancel out. And basically it's 1,000 times 4, which is equal to 4,000 milliliters. So if we were to write this in scientific notation, it would just be 10 to the 3. So sometimes if I have like a value that is like 2.65 liters, and I don't actually want to write out like the whole value in milliliters, and they want you to convert it to scientific notation, or like round off to 2 significant figures, you can say that this is the same thing as 2.7 times 10 to the 3, 10 to the 3 milliliters. So this is depending if your question wants you to round to only 2 significant digits. Let's see what our junior tutor said. The metric system uses prefixes that indicate multiplication factors. The prefix milli indicates a multiplication factor of 10 to the negative 3. To convert 4 liters to milliliters, we have to divide this by 10 to the negative 3. So they did 4 divided by 10 to the negative 3 is equal to 4,000 milliliters. Yep, so this is correct. So there are different ways of handling conversion factor questions. So this method, they know that the prefix milli indicates a multiplication factor of 10 to the negative 3 if you were to compare it to liters. So that's why they divided by this number. But I like to write out like the actual ratios just so I can visually see my units canceling out, because when I was a student I'd always like get confused of when to divide, when to multiply. So it all just depends on um, what you favor as a method. Okay, so that solution was still correct. So now this question asks, how do you convert milliliters to liters? Okay, so I started a new page since it's a new question, but let's just recall again. 1 liter is equal to 1,000 milliliters. So let's say we had a question that says, what is 325 milliliters in liters? And then I'm also going to say, let me change this to like 3. Express answer using two significant digits using scientific notation. So we just bumped up the conversion questions up a notch. But we're still going to use my same go-to method of first writing X liters, since this is what we're looking for. 323 milliliters at the bottom. And then on the other side, liters are on top, milliliters are at the bottom. Multiply both sides by 323. You'll notice that your units should cancel out. And if you don't have a calculator and you need to do 323 divided by 1,000, this is the same thing as moving your decimal to the left by 3 spaces. So we can show it going like 1, 2, 3. And our answer is 0.323 liters. So the second part of the question says to express answer using two significant digits using scientific notation. So to convert to scientific notation, let's say we had 3.2 times 10 to the -1 liters. So when I write scientific notation, I put my decimal after the first like whole number. And then when I compare it with my actual value, I move the decimal 1 space to the left. So that's where I got 10 to the -1 from. And then that is in liters. Let's see what our junior tutor said. The conversion factor between milliliters and liters is 1 liter is equal to 1,000 milliliters. Hence, to convert a value in milliliters to liters, the given must be multiplied by 1 liter over 1,000 mils. Note that liters is placed in the numerator because it's the desired unit, yeah? and milliliters is in the denominator so that it will cancel out. Hence, to convert milliliters to liters, the given must be divided by 1000. Yep, so this solution is correct. Okay, so I think that is all the time we have for today. Okay, so if you like today's Q&A and you'd like to be notified of when we do this next, then please hit the subscribe button and the notification bell below. If you like today's video, go ahead and give it a thumbs up and also comment. And also, if you'd like to submit a question of your own, then check out the links in the description below as well. Don't forget to share it with all your friends and classmates if they needed any help with chemistry. So this has been Donna from OneClass, and I hope to see you soon. Bye.